Okay. Okay, excellent. So the systematic review searches for existing articles that have answered the question and extracts from those articles their results. So just before we dig into the systematic review, I wanted to show you some examples of papers. And for example, some econometric papers have investigated data to understand if climate change, the climate change that we have already suffered from, whether that has increased inequality. And here is an example of an econometric study that seeks to determine whether climate change has affected recent trends in inequality between countries since 1960. And to do so, the authors, they combine counterfactual historical temperature trajectories from a series of global climate models with empirical evidence of the relationship between historical temperature fluctuations and economic growth. And together, these elements enable them to generate country-level probabilistic estimates of the influence of anthropogenic climate forcing on historical economic output. And they show that although inequalities between countries have decreased over the past few decades, climate change has slowed that decline. And their quantification of the phenomenon reveals that the ratio between the wealth of the richest 20% of countries and that of the poorest 20% is 45% higher than it would have been in the absence of climate change. And while, of course, that figure of 45% is the median of their estimate, which includes a degree of uncertainty, they find a probability of 99% that the ratio has increased. So they answer that climate change already in the past decades have increased inequalities between countries. Here is another example, this time on inequalities within countries for 150 countries over the period of the beginning of this century. And in the study, the author quantify with some econometric methods as well. They quantify that a 1% increase in temperature is associated with a 0.5 point increase in the Gini index, and we'll come back to the Gini index later. It's a measure of inequality you probably know about anyway. And this is the average effect that they quantify across the panel of the 150 countries. But of course, it varies from country to country, and they show in particular that it is greater in countries where a significant proportion of the population works in the agricultural sector. So again, another type of the article that we wanted to include in our systematic review. So now the method of the systematic review is first to collect as many as possible of the relevant articles. And to do so, we construct a search query by combining keywords on climate and on economic inequality to search articles databases, in that case, Scopus and Web of Science. And we spent time designing that query, and we can talk about that if you want, but maybe it's not worth going into the details now. And so we collected about 1,000 articles, and after screening them to check for the actual relevancy to the question that we ask, we retain about 200 articles. So we have a set of articles to now analyze and in a systematic manner. And then, so we read all the articles and extracted the relevant information, first on the results that they find about the effect of climate change on economic inequality, whether a regressive effect is found, meaning that the paper finds that inequalities or poverty increase due to climate change, or that the poor are more impacted by climate change. So if that's the result the article find, we will code it as they find a regressive effect. They can also find a progressive effect, meaning that inequalities are reduced thanks to climate change. They can find a neutral effect. Climate change does not affect inequalities, or mixed effects, meaning that it finds both reduced and increased inequalities depending on some factors, maybe because that article has looked at different locations and find different things in the different locations, for example. And sometimes we also had a number of articles that didn't make an explicit conclusion on the effect of climate change on inequality, and we did not interpret further ourselves further than what the authors themselves stated in their papers. So that's why we have a number of no conclusion in our coding. And we code also information about the scope and the method of the paper. First, what type of climate impact it focuses on, whether it looks at the increase in mean temperature, or if it looks at extreme events, or sea level rise, or other types of hazards. Then we code what type of economic inequality it focuses on, whether it's inequality in income, in wealth, in consumption, or other types. We code the geographical scope and the granularity of the study, whether it looks at the whole world, a single country, or even a subnational territory. And what sort of methods it uses, whether it's an econometric analysis, whether it uses modeling, surveys, or other kind. And finally, we also code the channel that is highlighted, how, like the channel by which the climate impacts translate into inequality. For example, whether it's through labor productivity reduction, whether it's through physical assets destruction, or other types of mechanisms. So if we just map the literature, we see it's a fairly recent literature. Most of the articles are from the last decade. So there's some increased interest in the topic in the academic community. And we also see that even though it's an economic question, the articles are published, well, some in economic journals, but also and mainly in environmental sciences and climate science in particular. So it seems to be fairly interdisciplinary literature. We can also look at the geographical scope of the articles, excluding the ones that are global. And we see actually an uneven coverage of the literature with China, Brazil, US, and some countries in Africa, Nigeria and Ethiopia in particular, that are more studied than others. And for once, it's notable that European countries, in particular, are less studied. And we do not have any articles that studied Russia, Central Asian, or Eastern European countries. So there's some gap that some new research should try to bridge. Just giving some ideas. And now, looking at the results of that set of about 200 papers on whether climate change increases economic inequalities, Well, actually, the majority of studies, 67%, I think, find a regressive effect of climate change. So these are those in red and in the graph. The share is higher for studies with global coverage, as well as national to some extent, and very local scales. We have less studies anyway, so those are the numbers of studies. And for subnational scale, it's the level where most of the studies that find mixed, in yellow, mixed effects or even progressive effects. But those are a limited number of articles. Looking at where it is found that climate change increases economic inequalities, the countries with the highest numbers of studies are China, Brazil, US, and Ethiopia in particular. And then trying to understand how climate change increases, or what the evidence we have tells us about how climate change increases economic inequalities. We can first look at results by type of physical impact. And the proportion of articles concluding that a particular type of climate change impact increases inequality or has a greater impact on the poor, so still in red. It varies depending on the type of physical impact, from the lowest as 60% in the case of the effects of climate change on precipitation, to almost 90% for sea level rise. And a few studies find that the effects of climate change reduce inequalities, and most of them are looking at extreme event as a climate hazard. And this is often because they measure the impact on physical assets, which are mainly owned by the wealthiest individuals. And so by destroying some of those physical assets, extreme events can reduce wealth inequality. So this is the channel of most of the results that find progressive effect of climate change. And several channels precisely and mechanisms that translate the effect of climate change into economic inequalities have been studied. These channels, they include effects on agricultural income through lower crop yields or livestock income, lower labor productivity, impacts on infrastructure and physical assets, changes in energy needs, in water availability, as well as effects on forests. For communities whose livelihood depends on forests. And the articles that identify labor productivity as the main channel through which climate change affects economic inequality mostly conclude that inequality increases, and a decline in labor productivity can indeed increase inequality if it doesn't affect all sectors and all income groups equally. And it's clearly the case, for instance, because in most of the location where this has been looked at, lower income groups are often more represented in outdoor working activities, and so suffer more of labor productivity decrease and hence income decrease than other income groups. And here too we find that the studies that identify a reduction in inequality are mainly the articles that look at physical assets as the channel for transmitting the effects of climate change on inequality. And these are where the wealthiest individuals suffer greater losses due to the higher value of their assets. So yeah, we saw that a majority of the studies conclude that climate change increases inequality. This finding applies to all geographical scales, all regions, all type of physical impacts of climate change, and all types of economic inequality studied. We also saw that there's some nuance, and that locally, for some channels, climate impacts may have mixed effects or even reduce inequalities. So if we take a step back and consider inequalities in losses and damages together with the contribution inequality, so the unequal responsibility for greenhouse gases emissions and the causes of climate change, we see what constitutes climate injustice. In fact, those who are disproportionately suffering from climate change impacts have the least contributed to the emissions that cause climate change. The historical responsibility for climate change and its effects lies with the rich and powerful, while the effects disproportionately affect the poorest and the most vulnerable. This is something that might be well known, but having some systematic reviews is useful to document the precise effects and channel. Yeah, and just again to show you some elements from IPCC report, that this climate injustice is precisely what that figure shows. So it's a figure from IPCC's sixth synthesis report that was published in 2023, and it shows that the countries that contribute least to greenhouse gases emissions are the most vulnerable to the effects of climate change. So the issue of climate change cannot be separated from that of global inequality. So this ends the first part of what I wanted to present, and to recap. So climate change impacts have increased and will increase economic inequality between and within countries. So mitigating climate change, limiting the effect of climate change, will reduce inequalities because the avoided impacts are regressive. However, mitigation policies also have distributional effects between and the level of mitigation ambition, how emission reductions are shared between countries, how policies are designed and implemented, which sort of policy instruments are used, and whether financial transfers between and within countries are provided. And so that leads to the question of how both sides would play out along mitigation pathways. Under what conditions would mitigation result in inequality increase or decrease? And that's precisely the question that the second paper is investigating, bringing together the inequality due to climate change impacts and mitigation policy effects on inequality. Again, it's a big topic. It's only one paper. There are many papers. So it looks at specific elements, and we can discuss about also what that paper doesn't look at, and limitations, and maybe other papers that are looking at complementary question. So the article, it's a numerical modeling paper that brought together 8 modeling teams to investigate the question of how within country economic inequalities could evolve in mitigation pathways. More precisely, it's what we call a model intercomparison study that designs a harmonized scenario protocol that several modeling teams run. And then we synthesize and compare results from the different models. The question it asks is, so how climate impacts could affect inequality within countries, how climate change mitigation policies could also affect inequality, and what role redistributive policy could play. And the idea is to quantify how these three channels compare and how the findings are robust or not across a diverse set of models and countries. So the paper gathers results from 8 models that vary in their regional disaggregation and in their modeling framework, in their assumptions and representation choices. But we can broadly group them into 4 classes of models: econometric models, computable general equilibrium models, detailed process-based integrated assessment models, and cost-benefit assessment models. I have no idea whether you're familiar with some of those types of models. I'm more familiar with some than others, and we can discuss technical details if you want in the discussion. So only the last class of model integrates, so the cost-benefit assessment models, they endogenously integrate a representation of climate change impacts. So for the other 3, and for that paper, a specific other model was used to add damages and their distribution on the modeled scenarios. And so the paper focuses on 10 countries that are individually represented in most of the models, but not all. And also those 10 countries to have like different characteristics in terms of development levels, in terms of current inequality levels, and in terms of energy systems and current emissions. So the model intercomparison protocol, it's set up around 3 core scenarios. One scenario is with no climate policy, so no climate mitigation policy, and we'll call it no climate policy. Then there are 2 scenarios that limit emissions to a 650 gigaton of CO2 carbon budget. That means that it gives about 2/3 probability to stay below 1.7 degree increase in global mean temperature above pre-industrial levels. We can discuss if that is compatible with Paris Agreement or not, but that's what is in the paper. And in both cases, the carbon budget is modeled with a uniform carbon pricing, of course, recognizing that this is not a realistic policy at all, but rather a sort of a benchmark to analyze modeling results. In one case, there's no redistribution, meaning that within countries, the revenues of carbon pricing are used in a distributionally neutral manner. And this scenario is called Paris in reference to the Paris Agreement on climate change that has the objective to limit temperature increase well below 2 degrees. It doesn't say anything about whether the implementation of the Paris Agreement should or should not follow that sort of logic. It's just the name, maybe mischosen, but that's the name of the scenario that is used in the paper. And in the other case, there is redistribution of the revenues from carbon pricing in an equal per capita basis. And in most countries, that is progressive, so it reduces inequalities because in all the countries studied, and we'll see that emissions increase with income. So if you have some carbon prices and then redistribute in an equal per capita manner the revenues, that will actually result into some gains for the lowest deciles and some cost for the highest deciles. And that third scenario in the rest of the paper is called Paris with EPC for equal per capita redistribution. In those three scenarios, impacts from climate change are included, either natively in the models or added with a specific module that was developed by some of the co-authors of the article. And there's also a fourth scenario, a counterfactual scenario for comparison that has no climate policy, but also no impacts from climate change. So this scenario is called reference, but be careful. This point of reference is an impossible world because it ignores the impacts from climate change that do exist in the real world. And we also did some sensitivity analysis with higher carbon budget. So to report how inequality evolves in the different scenarios, we need an indicator to measure inequality within the 10 countries we're looking at. And there are many existing indicators. I'm sure you know many different and that have different strength or limitation. And here we chose to use a Gini index, which is one of the most commonly used indicator for measuring inequality. And are you all familiar with Gini indexes? I see some no, I see mainly yeses, but I see some no. So I'll give you a sense of what a Gini index measures, and let me introduce the Lorenz curve. So we build a Lorenz curve by ranking the population studied in ascending order of income, or of the variable that we are interested in, but here it's income. And we plot the cumulative share of total income against the cumulative share of the population. So the cumulative share of the population here and the cumulative share of the total income in the society, in the country we're looking at. So for example, here in that totally illustrative case, we see that in that population, the lowest, the poorest 50% have earn about 14% of total income in that country. And so if the Lorenz curve would be here, we would have perfect equality, and if it would be like this, we would have one individual having all the income and all the others nothing. So the area between that line of perfect equality and the Lorenz curve is a measure of inequality, and the Gini index is actually twice that area, A. And so it can range between 0 for perfect equality to 1, the absolute inequality with one individual having everything. And the lower the index, the lower the inequality level, right? Is that what you had in mind? Okay. And is that clear for the ones who were not familiar with Gini index? Okay. And to give you an idea of the actual values of the Gini index in the 10 countries studies, here are the trends for the past decades. So you see here China, for example, the US in blue, here France, pretty flat here, India at the bottom, and at the top, so the highest inequality levels in Brazil and South Africa. And what you can see also is that a 10 percentage point of Gini index, so we're at 0.1 here, and this graph is already a large variation in the Gini coefficient. For example, the difference in Gini coefficient between France and the US now is about a 10 percentage point. And it's usually more or less the range in which Gini coefficients have varied over the last decades for individual countries. For instance, if you look at the US in blue, the increase in inequality since the 70s is equal to about 5 percentage points increase in Gini coefficients. Other indicators looking at the tail of the distribution, like the 1% or even 0.1% would look differently, but that's what the Gini index looks like. And so now we can look at the results. So looking into the future, how Gini index could evolve along the scenarios that are modeled. So first, for the no climate policy scenario, the results, they are presented as changes in Gini coefficient in percentage point from the reference scenario. So the one with no climate policy and no impacts from climate change. Each point represents a country for each model, and models are in different colors. So in the absence of mitigation policy, we find that inequality increases in all 10 countries and for all models except for NICE model, but that has that assumption built in its representation. And the inequality increases the most in the long term, which is no surprise because over time climate change increases and its impacts increase. So here we find like the same stylized results that we had in the systematic review. Impacts of climate change are regressive. We can see the countries where the Gini index increases the most. That's India, Brazil, and then Mexico and the US. And now we look at the second scenario with mitigation policy, so with less climate change and less climate impact, and distributionally neutral use of carbon pricing revenues. And here, the results depend more on the country and on the model. But overall, without redistribution, inequality increases in most countries for most model. It also depends on the time horizon. In the short term, mitigation policies tend to increase inequality compared to the no policy scenario. But in the medium term, and especially in the long term, mitigation policy reduces inequality because it reduces the impacts from climate change that are regressive. And again, if we look at the countries, we see that in the long term, for all countries, mitigation policy reduced inequality compared. So we can either compare to the reference scenario or compare the two lines to compare no mitigation policy with mitigation policy. And so for all countries, in the long term, mitigation policy reduce inequality compared to no policy, and all the more in countries where impacts were increasing inequality the most, so India, Brazil, Mexico, and US, but also China and Canada here. But in the short term and medium term, there are some slight increase in inequality, especially in some countries, for example, Canada, where mitigation policies appear to be regressive. And this results confirm concerns about the regressivity or the potential regressivity of carbon pricing, notably due to changes in prices, in energy prices, and countries with high carbon intensity, in particular South Africa, for example, or with high fossil extraction, Canada, in our sample of countries, are the most affected by this short-term regressivity of mitigation. And just to give you an intuition of why carbon pricing without redistribution is regressive, we can look at the energy share for housing and transportation across country and for the different income deciles. So you have here the first decile, so the poorest decile households, and here the 10th decile, so the richest households. That's for energy and housing, that's for energy and transportation. And they show a strong regressive pattern for residential energy consumption. So the energy share of household budget is the highest for the poorest households. While for transportation, well, it depends a little bit on the countries, but it is in most cases progressive. The budget share is increasing with income, especially in emerging and developing countries. For France, it's different, and we can discuss French case if you want as well. But because usually energy and housing is higher than energy and transportation, this is what dominates the effect and leads to the regressive effect that we find. All right. But so the carbon pricing, it represents also revenue for states that can be used to implement progressive redistribution, and that is what is tested in the last scenario, where the carbon prices revenues are redistributed within countries in an equal per capita manner. And so when doing so, redistributing as a climate dividend among citizens, the combined effect of climate impacts, climate policy, and redistribution becomes, with high agreement across models, inequality reducing, especially in the short term. And over time, as carbon revenues dry up because emissions are reduced, the inequality benefit of that revenue recycling, revenue redistribution diminishes. And by mid-century, the Gini remains lower than in the other cases, and it's roughly equal by the end of the century. And but if we compare also with the other scenario, we see inequality reduction in all time horizons compared to the no-policy scenario. And looking at the effects per country, we find inequality reduction due to carbon pricing, revenues redistribution. That effect is higher in developing countries or emerging countries, in particular India and South Africa, that show the highest inequality reduction given their lowest level of income among the poorer deciles, and also the most progressive redistribution because of how consumption of energy is distributed across the different income categories in those countries. So, okay, these are the results for inequality as measured by the Gini index, and we find that the combined effect of climate impacts, climate policy, and redistribution becomes inequality reducing. But looking at inequality is also not sufficient, because we could have cases where inequality could be reduced, where in fact everyone would be worse off. And so ultimately what is important, what matters for a society is welfare. And so to quantify the effect of welfare, we compute another type of indicator, the equally distributed equivalent level of consumption. which corresponds to the amount of consumption per capita that, if perfectly equally distributed, would yield the same welfare as the actual distribution in the country. So if that indicator is higher, welfare is higher. And we can discuss also the details if you want. And then this figure, it's the same, but for the change in that welfare measure. And we see in the top row, in the scenario with no mitigation policy, the impacts of climate change translates into welfare losses that increase over time in all models. If there's some mitigation policies, but without redistribution, the second row, the welfare decreases early on due to mitigation policy costs and a small increase in inequality that we saw, and it stabilizes around 5% by mid and end century. And with redistributive transfers, the last row, welfare increases on average in the short term. That is, the redistribution effect overcompensate for the aggregate mitigation cost from a welfare perspective in the short run, and this shows the crucial welfare benefit of redistributive policies. And then the benefits of redistribution vanish or diminish in the longer term when carbon revenues dry up because the emissions are reaching net zero in those scenarios. So there's no more carbon pricing revenues and even a need to finance negative emissions. And so in those cases, welfare losses, we have some slight welfare losses in the medium term. And then in the long term, the welfare gains from maintaining global warming below 2 degrees are still dominant. If we compare that row to that row, we have some welfare gains here. Okay. So overall, we find that stringent climate policies can generate important welfare benefits over the long term. And we find also substantial inequality reductions and welfare gains in the short term due to carbon revenue redistribution. However, we identify that mid-century as a potentially critical period when carbon revenues dry up and negative emissions need to be financed. And so with the specification we have, at least the climate benefits at that time horizon do not yet overcompensate from the climate mitigation policy costs. And yeah, so that means that in the medium term, there's the need for the implementation of new welfare enhancing policies that are designed for net zero times beyond the traditional instruments of carbon pricing with transfers that we've investigated in that paper. And of course, all our results, they depend on the relative magnitude of climate change damages and mitigation policy costs. And in that modeling study, we took very conservative estimates of climate change damages. You might know that there's, at the moment, big debates about the size of the economic damages from climate change, the cost of inaction. And so in that study, we were cautious and we took relatively low estimates to show that even with low cost of damages from climate change, we see that we have some welfare, some inequality reduction, and welfare gain from mitigation. Yeah, I think that's all what I wanted to tell you. Maybe just to recap, in 2 sentences, what we saw: impacts of climate change are increasing in economic inequality, both between and within countries. We have a lot of evidence on that. And mitigation policies, if designed with attention to distributional effects, can reduce inequalities within countries and enhance welfare. Thank you for your attention, and looking forward to the discussion.